Today we'll start section 4.6, multiplying and dividing monomials. To do this, we use the product of powers, which states that a to the m power times a to the n power equals a to the m plus n. Now this sounds more difficult than it is. If you recall from section 4.2 what the base and the exponent is, it will make this very simple, because when multiplying powers, we do not multiply the bases. The base stays the same, and we add the exponents. So in our example, 3 to the second power times 3 to the fourth power equals 3 to the second plus fourth power equals 3 to the sixth power. To show how this works, we have 3 to the second times 3 to the fourth. 3 to the second is 3 times 3, and 3 to the fourth is 3 times 3 times 3 times 3. Let's add another one on there. In the first one there's 2 factors, and in the second one there's 4 factors, and when we add them together we have 1, 2, 3, 4, 5, 6 factors. Let's look at another example. 9 to the third power times 9 to the second power equals 9 to the 3 plus 2 equals 9 to the fifth power. A second example shows us that 3 times 3 to the fifth power equals 3 to the 1 plus 5 equals 3 to the sixth. Now the problem with this one is a lot of times students will forget that there's actually an exponent with 3. Recall that 3 can also be written 3 to the first, and whether there is a 1 there or not, we need to remember to add it to any other exponents. Let's do a couple together. In guided practice number 1, we have 5 to the fourth power times 5 to the sixth power. In order to solve this, we would have 5 to the 4 plus 6 power, or 5 to the 10th power. In guided practice number 2, we have 4 times 4 to the 7th power. Remember that when we have 4 by itself, it is actually with an exponent of 1, so 4 to the 1 plus 7 equals 4 to the 8th power. Notice that in neither one of these examples did we add or multiply the bases. The bases of 5 and 4 remained the same. All we did was add the exponents. Here is your first self-check. Go ahead and pause the video and work this self-check on the back of your notes. Put your answer on your note sheet and also on the notes that you submit to me online. And then proceed to the next example. Next, we are going to multiply monomials. Recall that a monomial is a number, a variable, or a product of numbers and or variables. Let's look at the examples together. In example 3, we have a times a to the fifth power, which would be written as a to the 1 plus 5 power, or a to the sixth power. In example 4, we have n to the fourth power times n to the fourth power. We could rewrite that as n to the 4 plus 4 power, or n to the 8th power. In example 5, we have to do a little bit more work to solve this one. We have negative 3x to the second power times 4x to the third power. The first thing we're going to do is pull out our coefficients of negative 3 and 4. Remember that the coefficient is the number that comes before the variable. We'll pull those out, and then we'll take x to the 2 plus 3 power. We'll multiply negative 3 times 4 and get negative 12, and then x to the fifth power. So the answer would be negative 12 times x to the fifth power. Let's do a couple together. In guided practice 3, we have n to the fourth power times n. This would be the same as n to the 4 plus 1 power, or n to the fifth power. In guided practice 4, we have coefficients before our variables, so we need to pull those out first. So our coefficients are 5 and 4, so we'll multiply 5 times 4, and then we'll take our base r and add the exponents 3 plus 4. Our answer then would be 5 times 4 is 20 times r to the 7th power. Now let's try some on your own. We have self-check number 3, number 4, and number 5. Work these problems out on the back of your note sheet. Put your answers on your note sheet and then also on the form that you submit to me online. Next, we are going to divide monomials. This may require you to look back to section 4.5 where we learned to simplify fractions, algebraic fractions, by canceling. So here we have 3 to the 8th power times 3 to the 5th power. To do that, we would multiply out 3 times 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 3, that's 8 factors, and divide that by 3 times 3 times 3 times 3 times 3, that's 5 factors. And when we cancel out the ones they have in common, that leaves us with 3 to the 3rd power, or 3 factors. Another way to do this would be 3 to the 8th divided by 3 to the 5th equals 3 to the 8 minus 5 equals 3 to the 3rd. So in dividing monomials, we actually subtract the exponents rather than add them. And again, our bases stay the same. You can see the quotient of powers rule is very similar to that of the product of powers, but this time we're dividing. A to the m power divided by a to the n power equals a to the m minus n. Some examples for you to look at are 4 to the 5th power divided by 4 to the 2nd power. We could rewrite that as 4 to the 5 minus 2, or 4 to the 3rd power. In the next example, we have 10 to the 5th power divided by 10 to the 3rd power. We could rewrite this as 10 to the 5 minus 3 power, or 10 to the 2nd power. The next example has variables. So we have x to the 3rd power divided by x. Recall that when x is alone, it still has an exponent of 1, so it would be x to the 3 minus 1, or x to the 2nd power. Let's do one together. In guided practice 5, we have 5 to the 3rd power divided by 5 to the 2nd power. This could be rewritten as 5 to the 3 minus 2 power, or 5 to the 1st power, which we could also write as just 5. Now it's time for self-check number 6 and number 7. In these examples, you will divide monomials. Work out the problems on the back of your worksheet, your note sheet. Put your answer on your note sheet, and then also put your answers on the form that you submit to me online. One thing I haven't reminded you of is how to show exponents on the online form. To do this, you would just put your base and then use the caret sign, the one that looks like a housetop, and then a number for your variable. So for example, if you were doing 3 to the 2nd power, you would write it 3 housetop 2, and that would tell me that you meant 3 to the 2nd power. Go ahead and try these self-checks and then proceed.